Hello everyone. In this video, we'll see what is transposition cipher. Um, Transposition cipher is it is a method of encrypting which rearranges the positions of the given characters without changing the characters themselves. So here we have to understand the difference between the transposition cipher and the substitution cipher. So there is another cipher called a substitution cipher where the given characters are replaced by other characters, whereas in transposition cipher, uh, the characters are just being rearranged uh, by the same having the same characters themselves. And also, transposition ciphers reorder the units of the plain text according to a regular system to produce a cipher text. Actually, that is the permutation of the plain text. Okay, so this is the definition of transposition cipher. So, as I said, it is a method of encryption through which the positions held by the units of plain text, which are shifted according to a regular system. And then the ciphertext constitutes a permutation of the plain text. That is, we are just changing the order of the units. Okay, so it is a cryptographic algorithm where the order of alphabets in the plain text is rearranged to form a ciphertext. Again, in this process, the actual plain text alphabets are not included. Moving on, there are many transposition ciphers are available, as you can see in the slide. Here, we are going to see only two ciphers. One is rail fence cipher, and the other one is columnar transposition cipher. So firstly, we'll see what is this rail fence cipher. So this rail fence cipher is a form of transposition cipher that gets its name from the way in which it is encoded. So here we have to have an imaginary fence of having rails, okay, of given key lengths. So here, in the rail fence cipher, the plain text is written downwards on successive rails of an imaginary fence, then moving up when we get to the bottom. So here there will be a given plain text message and a numeric key. Then we will have this cipher and decipher the given text using the algorithm. And this rail fence cipher is also called as zigzag cipher. So we'll just see with this an example. So here an input is given. So here the input is hello world, and the key given here is 2. And you can see in the previous slide, there will be a given plain text message and a numeric key. So here the numeric key is 2. That means here we will have two rows, or we can see two rails, imagining ourselves as a rail fence. And as it is given, firstly, the first character is written here, and then it is going downwards to the next row, diagonally going downwards. So you can see the next character in the second line, which is diagonally downwards. And after reaching there, it will again go to the top row, again diagonally upwards. So likewise, all the other characters are filled in the same order. And finally, after completing all the input characters, and finally our output will be, it will be combined with the two different rows. So here we have two rows as per the given numeric key value as 2. So here the first row will be taken as one combination, and the second row will be taken as the other combination. So you can see the output as given. Here it is HLOOL and then ELWR D. So our plain text is hello world, and after doing this, after having this algorithm, and the cipher text is uh, the output what we have got. In the next slide, I have given you the explanation. So here, the order of the alphabets is rearranged to obtain the ciphertext, as I have already told you. So here, the plain text is written downwards and diagonally on successive rails of an imaginary fence. Then, when we reach the bottom rail, we traverse upwards, moving diagonally. And after reaching the top rail, the direction is again changed. So thus, the alphabets of the message are written in a zigzag manner. So after each alphabet has been written, and finally, the individual rows are combined together to obtain the ciphertext. So that is what we have seen in our previous slide. So this is about rail fence cipher. So in this way, we can encrypt our given text, and then we can form the ciphertext using rail fence cipher. Moving on, we'll see what is this columnar transposition cipher. So here it is again a form of transposition cipher. Here also, a plain text message will be given as an input, and then we will have a numeric key, and finally we will cipher and decipher the given text using columnar transposition cipher. So this columnar transposition involves writing the plain text in row wise and then reading the cipher text in column wise one by one. We'll just see this with an example. So here, the given input is hello world. And you can see the key given here is hack, which is HACK, hack. And then we have to check that, we have to see that the given key value is, or the length of the given key is 4, which is HACK, the length is 4. So based on the length, we are just building the column in a 4 length column. So in the very first row, you can see there is we have written the keys in each and every cell of the first row. And after that, we are making the ordering arrangements based on the alphabetical order. So here you can see number 1 is given to the alphabet A, and as per the alphabetical order, we are giving number 2 for alphabet C. So likewise for the other 2 alphabets. So here we can conclude that for the given key hack, our numerical key value will be 3, 1, 2, 4. All right. Now, after writing these two the key values, then we can just include our input inside the table. So here, as I said, the length is 4, so that we will have only 4 columns. So we are writing in the row wise. So starting from H, we are writing in a row wise. So you will see HELL. In the next row, we are writing OWOR, and in the last row L and D. And finally, you will have 2 cells as empty. So we are just filling those 2 empty cells with some duplicate or a dummy characters. So we are just including a dummy characters as X and Y. So with this, our columns are filled. All the cells are filled in this table. Now, as we have seen in the explanation, we have written in the row wise. Now, for reading our cipher text, we have to take from the column wise. So for taking from the column wise, we are going to have the numerical order. So firstly, we are giving to number 1, and in that particular column, we are just taking the characters in that column. So in that column, you will see E, W, D. So we are reading the characters in the column-wise order. And also, we are taking the numerical order-wise. So firstly, we are taking EWD and then going to the second one, which is LOX, and going to the third one, which is HOL, and finally LRY. So in this way, we can convert the given plain text, which is hello world, to its respective cipher text using the columnar cipher. So moving on, I have given you the explanation for the previous example. So in this transposition cipher, the order of the alphabets is rearranged to obtain the cipher text. Now, the message is written out in rows of a fixed length, and then we read out again column by column, and the columns are chosen in some jumbled order. Then the width of the rows and the permutation of the columns are usually defined by a keyword. So now in this example, the word hack is of length 4. So the rows are again of length 4. Then the permutation is defined by the alphabetical order of the letters in the keyword. So here in this case, the order would be 3, 1, 2, 4, as I've already explained it. And finally, the message is read off in columns in the order specified by the keyword. So in this way, we can have our ciphertext using columnar transposition cipher. Moving on, we are going to see one more cipher in addition to this, and I'll tell you why are we going for that cipher. So that one is called as double transposition cipher. So why are we going for this double transposition? Means since we have very less security in columnar transposition, we can implement this double transposition. So this is very simple to implement. Why? Because so here the reason why are we going here is so this could be attacked by guessing the possible column lengths, writing the message out in its columns, and then looking for some possible anagrams. So for making it stronger, we can use this double transposition. So this is nothing but, this is just simply a columnar transposition applied twice. So we are going we are implementing the same columnar transposition 2 times. Okay, so then we can have some additional security so that we can minimize the security threats. So the same key can be used for both transpositions, or we can use different keys also. So we have seen what is transposition cipher, and under transposition cipher, we have seen some 3 different ciphers. One is rail fence cipher, and how we can create ciphertext from the given plain text using rail fence. Similarly, from columnar transposition, and why are we going for this double transposition cipher? Thank you all. Thank you for watching. Have a good day and goodbye.